Welcome back to Maths with Mrs. J. I thought it was time for us to do another challenge. And if you know me, you know I absolutely love algebra, so I've picked a little algebra challenge here. This one is not particularly difficult. However, there are some useful strategies that I'm going to use that I'd like to point out to you. So I thought this would be a good one to do together. What we're being asked to do is we've been given a cubic equation and it's got some unknown coefficients. The coefficient of the x squared and the x term are unknown and they're both the same. They're both a. We're asked to find the values of a for which that equation has real roots. It's a cubic equation, so in theory, there will be 3 roots. However, we want to make sure that they're all real roots. We're not talking about complex numbers here. You've got a couple of options to get started with. You could call this polynomial p of x. So p of x is x cubed plus your ax squared plus ax plus 1. And you could try out a few x values to find when p of x is 0. It's pretty obvious that p of negative 1 is going to be 0 because you're going to get negative 1 plus a minus a plus 1. So equals 0. So therefore, using your factor theorem, you would know that x plus 1 is a factor. Then you could go ahead and do a polynomial division to work out what your quadratic component is. I didn't actually approach it that way because I had a look at this expression and I thought, well, this lends itself quite nicely to grouping. Not first 2 and last 2, but the first and last and the middle 2. And I'll show you what I mean. So we've got x cubed plus 1, and then we've got ax squared plus ax. Those first 2 terms are the sum of of 2 cubes, I should say. So when we put this into brackets, when we factorize this, we should know, by the way, that if we have a cubed plus b cubed, that factorizes as a plus b, a squared minus ab plus b squared. And if you're not sure about that, do your full-on expansion and you'll see that all your middle terms will cancel out. So x cubed plus 1 will be x plus 1 times x squared minus x plus 1. Then for my remaining 2 terms, I can take out an ax as a common factor and I'm left with x plus 1. Now you should notice there that we have a common factor that can be brought out the front. So we're going to have x plus 1 and then we're going to have x squared minus x plus 1 plus ax. And let's just tidy that up a little bit. So we've got x squared. With our x term, we've got really an a minus 1 lots of x plus our 1. Okay, it's pretty obvious that that will give you a root of x equals negative 1, and negative 1 of course is a real number. So that's perfectly fine. That's never in danger of causing us an issue. However, what we need to now look at is this quadratic component, and we need to make sure that we find the a values for which the roots of that will be real. We have done a series of videos about quadratic equations, and you may or may not recall that when you have a quadratic equation in the form ax squared plus bx plus c equals 0, that your discriminant, which is the part of the quadratic formula that's under your square root sign, it's your b squared minus 4ac, and that is a very important part of that formula because that determines what sort of roots you're going to get to that equation. Now, if the discriminant is negative, we will not get real roots. Okay, so we are asked, it needs to have all real roots. So we need to ensure in this case that this discriminant is at the very least 0. It can be 0, that would give us repeated roots, and that's okay. But it cannot be negative or we would have complex numbers coming in. All right, well, what's the discriminant of this? Well, your in essence, b squared minus 4ac here is going to be a minus 1 squared minus 4 times 1 times 1, which is a squared minus 2a plus 1 minus 4, right? What does that look like as a graph? Well, in this format, if you had y equals a minus 1 squared minus 4, you should know that this is like your normal parabola that's being shifted 1 to the right and 4 down. So your turning point's going to be there. Having a look at this, if we factorise this, we get a minus 3, a plus 1. So the a values, if you like, the a intercepts will be 3 and negative 1. So this parabola, if we were graphing y equals a minus 1 all squared minus 4, we're going to get a parabola like this kind of situation. Now, we need to know what a values will ensure that this particular value is at least 0, 0 or above. Having a look at our graph, it's pretty easy to see. So obviously this section of the graph will be okay, and this section of the graph will be okay. So obviously, so that equals 0 if a is 3 or negative 1, and it's greater than or equal to 0 if a is less than or equal to negative 1 or a is greater than or equal to 3. So that will be the answer that will give us all real roots to that equation.